Okay, we are going to go over this question that we did in class just so we can see it. I'm just going to move my board over a little so we see more of my document camera because we're really going to do most of our work here on the document camera paper instead of the whiteboard, okay, because it's easier to write on paper. So we have a cell phone plan that costs $70 per month and comes with a free phone. So $0. You don't have to pay for the $500 phone. Cell phone plan B costs $50 per month but does not come with a phone. Okay? You have to buy the phone. If you have to buy the $500 phone, which phone plan will you choose? All right, so we have to decide which would be the better deal, but then we're also going to be thinking how many months is it until our plans cost the same amount of money? So we're thinking about two different situations and where do they meet? Where do they connect? Where do they cross? Where do they come together? So we got to think about this as two different equations. I have plan A. So let's think about what we know about plan A. Plan A is $70 per month, okay, with a free phone. Okay, free phone. No additional cost, right? No additional cost. Plan B is $50 a month, but you have to buy that phone. So that is a plus $500 for the phone. So what we have here is two basic equations. We have a y-intercept and we have a rate, okay? So this right here is my rate, okay? That would be my rate, my constant, my slope. All of these are the same, okay? This is my okay? My rate, my constant, my slope, okay? The per month. Now, back in 7th grade math, when we were doing 7th grade math, we talked about function tables, right? And we talked about our x and our y, okay? And we said that what we do to x will give us y, right? So y is always equal x times something. That per is my rule. So I have this would be my per month. So this would be my months. Something times something equals something, right? My y would be my cost, right? My total cost. So $70 per month. If I pay 1 month, and I do $70 per month, then it's going to cost me $70, right? Now, this is what we call proportional, right? Because it's free phone. So we would call this a proportional relationship because we don't have that plus or minus anything. But on this side, we actually have a little bit more of a complex equation. So for this x and y, okay, I have something times something plus something equals something. See that? So we have two parts to our equation. $50 per month plus 500. So that's my 50 times 50 plus 500, right? So this is a two-step rule, times 50 plus 500. $50 per month plus 500. So if I do 1 month, 1 times 50 plus 500, my total cost is 550. Okay, so we have two very different situations here. Now, if I write these as equations to make it easier for me to understand, I have my total cost, and I'm going to do a little color coding here just so you can see it. Let's do my y is my total cost. So y is equal to my rate, which is 70. That's my slope per month. So let's make that our x. And then I don't have a y-intercept. There is no y-intercept. So I do have a y-intercept on the other one. So I'm actually going to use a different color here. I'm going to put plus 0, right? I get a free phone. There's no y-intercept. I don't come into the store having to pay something at the start. So this is why we call this a proportional relationship, okay? So it is just y equals 70x. And then I'm going to rewrite that down here at the bottom. Y equals 70x. That's plan A. All right, plan B is a little bit different. We'll use the same colors. My y is my total cost. That's what I'm trying to figure out. And I know my slope is 50. And then there's my x, which I'm still trying to figure out, my number of months, right? That's my months. I don't know how many months it's going to be until the cost is the same. But now I have this extra. This is my y-intercept plus 500, okay? That would be my y-intercept. This is what I'm paying to walk in the door before I even start, okay? So my graph is going to start at 500. 50 times some number of months plus the 500. So plan B is y equals 50x plus 500. It's non-proportional, okay? Now, if I were to sketch these two graphs, and I can do a quick sketch, it's pretty easy. I'm not going to obviously do it by rate or by scale because this is 500, but I'm just going to do like a quick, okay? If I were graphing this, y, x, it's going to look something like this, okay? I'm paying $70 per month. I'm starting at 0, 0, and I'm just working my way up, paying each month 70 times 1, 70 times 2, 70 times 3, 4, 5. This one is going to be climbing not as steep as this because it's $50 per month, not 70. So it's not going to be as steep. But I'm starting my graph. I'm coming in way up here, right? At the 500 mark. So it'd be something like this, right? Okay? So this is starting at 0, increasing. This would be 50x plus 500. The 500 would be my y-intercept. Okay? 0, 500. It's where it starts, not at 0. Okay? All right. So these two lines are going to intersect. They are because they don't have the same slope. So they're not parallel. And as they go through time, as they're moving through time, they're going to eventually go together and they're going to crisscross. And our goal is to try to figure out where they cross. Now, in class, we did guess and check. We went down and we just did times 5 months, times 10 months, and it took us forever. Remember, I mean, we were sitting here working on this for probably 30 minutes before we figured out where they crisscrossed. There is an easier way. If you want to know where these two equations are the same, right, because that's what we're trying to do. We're trying to figure out where this plan and this plan are the same. We're going to have to put them equal to each other. So we're going to set up an equation, and we're just going to put these two equal together. Now, I know it says y equals. I don't really care about the cost right now because that's not what that's not what it's asking me. It's not asking me how much is the plan costing. It's asking me how many months. So I'm curious about the x. I want to know what the x is, and then I can figure out the cost in a minute. I can do that later. I need the x first. So I don't know how many months these two are going to be the same. So let's just set it up as an equation. 70x has to be the same as 50x plus 500. Okay, so I'm just putting my two equations equal to each other, my A and my B, because I want to know what makes them equal. What's that x going to be to make them equal? All right, so I'm going to zoom in, and I'm going to solve this. All right, so I'm going to take and use that equal sign, balance scale. Miss Breen likes to do that. This is actually a pretty easy equation because this is no y-intercept, so there's no plus, right? There's just a 70x, and on this side, it's a 50x plus 500. I don't want to get rid of my 500 because there's nothing over here to subtract it from. So he can actually stay. This is where I can make my zero pair. If I take 50 away from both sides, if I take some x's off of both sides, that's going to make my equation a little easier to solve. All right, so let's get rid of 50 from both sides. I'm subtracting 50 from both sides, 50 x's. Okay, so if you think about the balance scale, I'm just taking 50 x's off of both sides. On this side of the scale, I'm left with 500. And on this side of the scale, I'm left with 20x. Okay, So now all I have to do is finish my equation. 20 times what is 500? If you don't know what that is right off the top of your head, all we have to do is divide. Remember, our goal is to get x by itself. So 1x, I want 1x, I don't want 20. So I'm going to divide both sides by 20, okay? And that is x equals 25. You can use a calculator to check your math. 20 divided by 20 is that 1x. Remember, that's a 1x, and that's what I want. 1x is equal to 25. So, how many months? 25. Okay, so I would have to have this phone plan for 25 months for both of the plans to be costing the same amount of money. Now, I know this, if I think about this as an ordered pair, right, I know my x, so I'm just going to come over here and put 25 in for both of my x's, right? So I know my x, right? I know my x, but I don't know my y. I don't know my y. So I'm just going to kind of put a 25, comma, a y. Now, all I have to do is solve each of these equations using my x. So do you know how all the time Miss Breen is trying to tell you to check your equation? So once you get your x equals, you should always go back in and plug it in and make sure you have the same value on both sides. That's what your y is. My y is going to be what these two equal. That's going to be my y, the total cost for both plans. And they should be the same if I did my math right. Okay, so all I'm going to do is I'm going to take my 25, I'm going to rewrite my equation over here, because I always like to rewrite because it gets kind of messy. And I know I have 70 times my x, 50 times my x, plus 500. Okay? So all I have to do is plug in my 25 and solve. Now, you can use a calculator. No problem doing that. I'm going to pull my calculator up here. 70 times 25, and that equals 1,750. Whew, that's expensive, but that's 25 months of a phone plan. All right, let's see what this one equals. 50 times 25, and that's 1,250, but I got to add that extra 500. Remember, we got that y-intercept to deal with. That's our plan is starting at 500, so we can't forget about that. Look at that. They are the same. Okay? So now I know my y. 1,750. 1,750. So after 25 months, these two phone plans will cost the same amount of money. Now, we talked in class about why do we need to know this information? Well, it depends, because depends on what type of person you are. Can you make a phone last for 25 months? Because if you can't make a phone last for 25 months, then this is probably your better deal, because you're going to want to get a phone before the 2 years is up. So if they're giving you a free phone and it's a pretty decent phone, this is probably the better plan. But if you take good care of your phone and you can make your phone last for over 2 years, after the 2-year mark, or 25 months, which is 2 years and 1 month, your rate is only going to be $50 a month, where this is going to be an extra $20. So again, it really does depend. There's no right or wrong answer, but this is where we can calculate and figure out the number of months and the total cost. So after 25 months, both phone plans will be costing the same amount of money. Now, when we did this in class, guess and check, it worked, but it took us forever. Remember, we kept trying 10, 20, 15, all kinds of numbers until we finally hit the mark where they met. Putting our equations to equal each other and then solving the equation is a more efficient way. Okay? I hope that helps. You can use this strategy on any equation if you're trying to figure out what would be the same value for these equations. Now, there's a certain type of equations where you can skip this method. You don't really have to deal with that. And that would be when you're dealing with equations that have the same slope. So if someone presented you an equation that was like 3x plus 8 and 3x plus 7, these two are never going to meet because they have the same slope. So these are what we call parallel. Okay, parallel because they have the same slope. So these two same slope. These two we call have no solutions. No solutions. So you could just save your time, save yourself the effort. They're never going to crisscross. And you say, well, Miss Breen, well, wait a minute. This one says +8 and this one says +7. Well, that's the y-intercept. The y-intercept is where the graphs start. So these two do start at different spots, but they will never intersect. So if I were to sketch, it would kind of look like this. If this is 7 and this is 8, the lines are going to look like this. Okay? They have the same slope. They're just starting at two different parts of the graph, two different points. So you would say, you wouldn't even bother because you're going to look and say, oh, they're both the same slope. Now be careful because there are times where they will try to trick you and they'll say something like this. Okay? And you'll go, oh, wait, these are the same. Well, they are, but they're not. One of them is negative and one of them is positive. And they could even have different y-intercepts. So I could say this one is 1 and this would be a negative 3x plus 8. They could have the same y-intercept. They could have different y-intercepts, but they are different lines. That's because this one is negative. This is a negative slope. And this is a positive slope. So yes, they look the same, but they're actually going in opposite directions. So if I were to sketch these two, my 3x plus 1 looks like this, and my 3x negative 3x minus 8 looks like this. Okay? And they do crisscross. All right? So just be on the lookout for that. If they have the same slope, they will never intersect. Therefore, they will have no solutions. But be on the lookout. Negative, positive, they do crisscross. Always crisscross. All right, so this one, let's look at this one real quick before we go to the video. Here's an example where there would be many solutions. Okay, so you have crisscross, which is one solution. You have parallel, which are no solutions. And then sometimes you have them where they have many solutions. Many solutions is they're the same line. So if they're the same line, the same equation, that means there's all kinds of solutions. We could sit here all day long. Okay, so how do I know if something's the same? So these two equations look different, but they're actually the same. So if they are the same, we would have many solutions. So one solution, no solutions, many solutions. So I have y equals 3, 2x plus 1 minus 4x. And then I have this equation. Now this equation is good, right? This is in simplest form. This is a mess. This is a mess. Okay, so we're going to fix this. Remember, we've been practicing this. Distribute, combine terms. Okay, these are the things you need to do when you have messy equations. Okay, so distribute, combine terms, because you want to organize. All right, that's your goal, is to organize. You need one variable and one number. One set of variables, one set of numbers. So let's see what happens when we fix this. Let's use the distributive property first. All right, 3 times 2 is 6x. So 3 groups of 2x and 3 groups of 1. Then we have the negative 4x. Okay? All right, so now I've just distributed. Now I'm going to combine terms, and if I look carefully, I see I have a 6x, a negative 4x. I only have a 3. And look, I have a 3 here too, so now I'm looking. Oh no, maybe these are the same. 6x minus 4x is 2x, and my 3. So these are the actual same equation. See that? They're the same. So if we are looking at them on a graph, they're going to have many solutions because they are the same equation. So any x and y on this would work because they're the same. So be on the lookout for that, okay? So we have one solution, no solutions, and many solutions. Many solutions are the same. No solutions are the same slope, right? So they're parallel. And one solution means the lines are not anything the same. They don't have the same slope and they're not the same equation. They're just two different equations. They will intersect all the time. They will always intersect at some point. And that's where you use the math to try to figure out where they intersect. Okay?